Hello friends, welcome to 5 minute class. From this presentation onwards, we are starting with new chapter called linked list, and in this particular presentation, I will introduce what is linked list all about and how it look like. So let's get started. We want to arrange the names of the students according to the first letter of their name. So this is our target. Here we are given some list of names and we want to arrange them in a sequential list or sequential orders. So this is the way how it look likes. So the question is how to do it, and this is how the order look likes. Here the first Dinesh, then Harry, then John, then Monty, then Ram, then Salman, then Tony. These are the names arranged in the sequential order according to the first letter of the names. So now the question is how to maintain this list in the memory. In order to maintain the list in the memory, there are two ways. One is array data structure and the second one is the linked list data structure. By using these two data structure, we can maintain the linked list in the computer's memory. In previous video, we have already seen the array data structure for implementation of the linked list. In this presentation, we'll see the linked list data structure. Arrays have some limitations and disadvantages as we have already seen in the previous video. If you have not seen the previous video, I will give you the link in the I button. You can go to the video and watch the difference between the array data structure and the linked list data structure. But for now, we will see what are the different types of the linked list available with it. The first one is single linked list. In the single linked list, the navigation is forward only. Navigation means we can move or we can traverse the data from the first node to the last node. Next one is doubly linked list. In the doubly linked list, the navigation is in both the direction, that is in the forward as well in the backward direction. Means here we can traverse the list into the forward as well as in the backward direction. Of course, the last one, the circular linked list. Here, as its name says, circular, that means the last element is linked with the first element. So in this way, it looks like the circular linked list. Now we will see how to represent the single linked list in the computer's memory. Suppose we want to store a list of numbers. These are 34, 20, 56, 43. For this purpose, we need to create four different nodes. Since we are having four elements to be stored, so the four nodes are required. The first node will hold the data 34, the second data will be stored into the second node, 56 will be stored into the third node, and 43 will be stored into the data part of the fourth node. Since we are talking about the linked list, so the nodes are stored onto the random memory locations. It is not required to be stored onto the sequential memory locations. So they may be stored some in random locations, like the first node is stored at location 1500, the second node is stored at 2000, the address of the third node is 1000, the address of the fourth node is 3500. As we know that in the array data structure, the elements are stored onto the contiguous memory locations or the sequential memory locations. But we know that in the linked list, the locations need not to be contiguous. These nodes are required to be connected together. So the address of the next node will be stored onto the link part of the previous node. So we can see here in the link part of the first node, 2000 is stored. So 2000 is the address of the next node, that is the second node. In the second node link field, the value is stored at 1000, which is the address of the third node. In the third node's link field, the value or the address is stored as 3500, which is the address of the fourth node. And a null is stored in the link field of the fourth node. As this is the last node, this is not connected to the any other node. So the null is stored onto the link field of the last node. So now the all the nodes are connected together. So how to access this linked list? So the linked list is accessed with the help of the address of the first node. So the address of the first node is stored onto some pointer. Suppose it is called as start. So this start is a pointer which holds the address of the first node, so which is currently 1500. So we can represent it with the help of the arrow. So now we'll see the pointer implementation or the dynamic implementation of the linked list. So for that we have to create the node. The node is to be declared as a structure because it consists of the two parts, info and the link part. Info field contains the value which is to be stored, and the link part or the link pointer contains the address of the next node. So it is a structure. How to create a first node? So for creation of the first node, we have to initialize the start pointer with the new node, and then we'll copy the item or the data into the info field, and the null will be transferred onto the link field of the start pointer. So this way, a node, a first node will be created and it will be pointed by the start. So you can see here in the example that in the info field we had assigned a value 5, and in the link field a null pointer is assigned or the null value is assigned because it is the only node into the current linked list. Now we will see the creation of the linked list with the three nodes. So initially the start equals to null because the linked list is empty. That means the start pointer will be having null value. So if we want to create a linked list having only three nodes, we can run the loop for I equals to 0 to 3, and we'll have the steps temp equals to new node. So this will create a new node, and then in the second step we will copy the item into the info field, and in the next step we'll assign the address stored onto the start into the link field of the temp, and in the next step the address stored inside the temp will be assigned to the start pointer. So the new node will be created at the front of the linked list. We can see with the example here that initially the start equals to null. We have created that node and we assigned some item value 5 onto the info field. We had signed the null value onto the link field, and then start equals to temp. So start will start pointing to the temp node. Similarly, this process will be repeated for next two nodes. Thank you so much guys for watching this video. Please subscribe the channel and like and comment.